Let us next look at what parts actually make up a Hadoop cluster. So there are basically 5 different types of nodes or 5 different job descriptions based on which the nodes can be separated from one another. The first one is the name node. This basically holds the metadata for the Hadoop file system. The second is the secondary name node, and this maintains the logs and updates those for the name node. Third is the data node that actually contains the data block, the job tracker, and then the task tracker. These two are responsible for map reduce jobs. Let's look at each one of these in a little more detail. The first one is the name node. Now this is responsible for storing the file system information in a file store image. Okay? And any updates that are required to the file system, for example, adding or removing blocks, removing files, do not change the FS image directly. They are rather written to a log file. Okay? And this log file is later committed to the actual node or name node. When starting the name node, loads the FS image file and then applies the changes in the log file. So every time we restart it or this sort of gets booted, then the information that is stored in the FS image is committed. The secondary name node, as the name might imply, secondary name node seems to be the backup of the name node, but this is not actually a secondary storage or a backup of the name node. What it rather does is it reads the log file, which was being maintained by the name node, and applies the changes to the FS image file and brings it up to date. Okay? So everything that the name node was putting in the log file is actually committed to the FS image using the secondary name node. So it maintains or it keeps up to date the FS image that is required for the efficient working of the name node. Okay? So it allows the name node to restart faster when required. Since these changes were also committed when the name node had to restart, so if the secondary name node has already committed the changes, then it is easier or let's say faster for the name node to restart. Next, we have job tracker and task tracker. Now, the responsibility of job tracker is that it determines the execution plan for the job. Okay. Job is one big process, and this process is split into individual tasks. And job tracker's responsibility is to keep track of the whole job or the big or complete process. ठीक है? पूरी जो एक बड़ा सा काम मिलता है कि let's say हमने 3000 records sort करने, so that's one job. और उसको हमने फिर फर्दर टास्क में डिवाइड कर दिया कि हर नोड ने 100 records sort करने, तो those are the individual tasks. Job tracker's responsibility is to create this execution plan for the job. इसको split कैसे करना है, कौन सी nodes को देना है, और फिर जब nodes हमें वापस डाटा दे रही होंगी तो how to get all that in one single form so that it can be produced as output. Task tracker keeps track of the performance of the individual mapper or reducer. अब वो जो individual tasks थी या जो सब jobs हमने create कर दी थी smaller ones, उनको कैसे execute करना है और उनकी performance कैसे हमने mappers को कैसे assign करनी है, reducer से कैसे वापस लेनी है, that is the responsibility of a task tracker. The fifth node, which was the data node, simply holds a cluster or a set of data for our Hadoop distributed files. Next, let's see what the Hadoop distributed file system contains. Some of the basic concepts, let's start off with these. Now, this sits on a native X3 XFS file system. Okay? These are the Unix file systems. So this basically shares the core or shares the same principle that the Unix file system had. It works with modest number of large files. Too many files or too small files are not the optimal solution for this. Then HDFS files are right ones. Even if we have to update something, it is written again. So there is no concept of actually updating it. Rather, a new copy is created that is considered the fresher copy or the updated version of anything. Then HDFS is optimized for large streaming reader files. Since the whole idea is distribution, so it uh, is best suited for files that have a substantial size. Okay? And from these, if you need to read records or most of your operations are read-only operations, then HDFS is the best solution. Now, Hadoop file system, just like any other file system, organizes data into files and directories. Okay? So the concept of directories is there just as in any other regular file system. And these files are divided into blocks distributed across cluster nodes. That's the only difference, that these blocks now reside on different physical clusters nodes instead of being co-located. So the block placement known at runtime by MapReduce is equals to the computational co-located with data. One important thing is that in order to handle failure of any node, these blocks are replicated. Okay? So there are at least 3 different replications of data. One is treated as primary and the other 2 are its backup copies. Checksums are again introduced in order to ensure data integrity. So that's again to make sure that the data that is placed has not been tampered with or destroyed by some means. Regarding replication, one and only strategy for error handling is this replication. Okay? Replication is done for error handling, for recovery, for fault tolerance. And that's what makes it self-healing. Since the backup copies can be used to recreate the original one, so we call it self-healing. And technically, there are 3 copies that we usually create, but there is no limit to how many you can have. You get 3 is the solution that works best. Any more than that would be unnecessarily redundant. Let's see graphically what we mean by a Hadoop file system or what the server roles are. These are the clients that communicate with our distributed numerous nodes. On the master nodes, we have the name nodes and the job trackers. Okay? And we have the secondary node. And these assign tasks to the slave nodes. The slave nodes contain the actual data and some task tracker. So the task tracker is responsible for checking whatever processing is happening on the slave node. And this processing takes the data from over here. So the data that is assigned to this node is being used by the system or processor that resides on this node, and the task tracker keeps track of what overall is happening. Okay? And then these report back to the job tracker. Okay? And this job tracker again then provides the output to the clients. And you can have up to 4,000 of such nodes. Okay? These processing nodes or slave nodes, you can have up to 4,000 of these nodes. A client can be connected to any core switch, and this again core switch will be connected to the name node and the job tracker and the secondary name node. And these would then again be connected with multiple data nodes, and on those data nodes we have those task trackers. Okay, so this is the basic structure of a Hadoop cluster.